Welcome back again, and this is Arup Basu from ClusterMicro. So today we are going to discuss immutable class design. So what immutability means and why it matters. Okay, so an immutable class is a class whose instances cannot be modified after construction. Once you create an object, its state is fixed forever. No method can change its fields and no external code can alter its data. You already know several immutable classes from the Java standard library: string, integer, all the wrapper classes, local date, local time, big decimal. So every time you call a method that appears to modify a string to uppercase, stream, concat, it returns a new string object. The original one is untouched. So why immutability matter, right? So three reasons the exam expects you to understand. First reason is thread safety. An immutable object can safely be shared between threads with zero synchronization. Okay, if no thread can modify the object, there are no race condition, no visibility problem, no need for locks. Immutability is the simplest and most reliable path to thread safe shared state. Okay, then safe as map keys and set elements. Okay, also it is very safe as map keys and set elements. So we learned that mutable objects used as hash map keys cause silent data loss if mutated after insertion. Okay, so immutable objects cannot be mutated, they are permanently safe as map keys. Then predictability. When a method receives the immutable object, it can trust that the object will not change under its feed due to another thread or due to the caller modifying it after passing it in. Okay, the OCP exam, it tests 5 specific rules for building a correct immutable class. So we'll go through each one. Okay, so here we have the code block: public final class money. Okay, then we have private final double amount, private final string currency. Then we have a constructor, public money. Then we have two methods: public double get amount and public string get currency. So rule 1 is declare the class final. So public final class money, right? A final on a class prevents subclassing. Okay, so no class can extend money. So why is this required for immutability? Because a subclass could override methods and introduce mutable behavior. Okay, suppose you did not make money final and someone wrote public class mutable money extends money and then private double secret amount, override get amount to return secret amount, and add set amount to change the secret amount. What will happen? Now we have a mutable money that passes as money. Okay, polymorphism, but is actually mutable. Code that expects an immutable money receives mutable money, and the immutability guaranteed is broken invisibility. Then final prevents this entirely. Okay, no subclasses can exist. Alternatively, if you have a legitimate reason not to use final, you can make all constructor package private and use a factory method. But final is simpler and more explicit. The exam expects final on the class. Then rule 2 is all fields must be final. So we have private final double amount, then we have private final string currency. So final on a field means it can only be assigned once, in the constructor or in the field declaration itself, and never again. After the constructor completes, amount and currency are permanently set. Any attempt to write this dot amount equal to new value outside the constructor is a compile error. Then final enforces immutability at the compiler level, not just a convention. Okay, the compiler physically prevents reassignment. Then we have rule 3, all fields must be private. Then we have private final double amount, private final string currency. Private fields cannot be accessed directly from outside the class, as we know. Without private, someone could write money object dot amount equal to 0.0 and bypass the immutability completely. So private and final together are the core protection. Private prevents external access and final prevents internal reassignment after construction. And rule 4, set fields only in the constructor, right? So we have public money constructor, double amount string currency, this dot amount equal to amount and this dot currency equal to currency. So the constructor is the only place where fields are assigned. Okay, once the constructor returns, the object is fully initialized and frozen. No static initializer blocks, no instance initializer blocks, no lazy initialization methods. All field assignments happen in the constructor. The object is complete and immutable the moment new money finishes. Okay, and rule 5 is provide no setters, no set amount, no set currency, no method of any kind that modifies a field. If a method needs to produce a modified version, it returns a new instance. It never touches this. Okay. Like we have given here, public money, add money other, then return new money, this dot amount plus this dot amount, this dot currency. So add does not add to this dot amount. It creates a brand new money object with the combined amount and returns it. The original money is untouched. The caller gets back a new object representing the result. So this is the pattern throughout string, local date, and every other immutable class. Okay. Methods that appear to transform the object actually create and return a new object. Okay. The original survives unchanged. Okay. Then if you see block 2, the mutable final field trap and defensive copies. Okay. The public final class schedule, private final date start date, public schedule date d, then this dot start date equal to new date d dot get time, public date get start date, return new date start date dot get time. Okay. So this is the most important and most tested immutability trap on the OCP exam. Money was easy, double and string are both immutable. You store them, they cannot be changed from outside. Very perfect. But what if your field is a mutable type? Java.util.date is mutable. It has set time, set year, set month, and other mutators. If you store a date reference directly and return it directly, your class is not immutable even if you allow rules 1 through 5 meticulously. Okay. So the broken version is what goes without defensive copies, right? If you put a public final class broken schedule as you see here, and private final date start date, public broken schedule date d, this dot start date equal to date, this dot start date equal to d, public date get start date, return start date. Okay. So what will happen is that first attack will happen mutating through the constructor argument. Okay. Date d equal to new date, broken schedule new broken schedule d dot set time. Okay. So it will modify the original date object, and schedule dot start date now will reflect the change. So it will get broken, right? So start date holds a reference to the same date object as d. The caller still has d, they call d dot set time 0, and the change is immediately visible through schedule dot start date. Okay. The supposedly immutable broken schedule has been mutated from outside now. Okay. And the second attack can happen mutating through the getter. If you have date return schedule dot get start date return dot set time 0, it will modify this date object. Schedule dot start date is now 0, so it is broken. So get start date returns the actual internal start date reference. Okay. The caller holds a reference to the internal object and mutates it directly. Again, the supposedly immutable class has been modified from the outside. Okay. So what is the fix? So we have defensive copies here. So public schedule date d, this dot start date equal to new date d dot get time, and public date get start date, return new date start date dot get time. Okay. So defensive copy in the constructor is instead of storing the reference d, we create a brand new date object. Copying the time value from d dot start date now points to a separate object. When the caller mutates d after construction, they are mutating their own object. Start date is unaffected. Okay. The external mutation cannot reach inside schedule. And then the second thing is defensive copy in the getter. Instead of returning the internal start date reference, we create a brand new date object copying the time value from start date, and the caller gets their own copy. When they call set time on it, they are mutating their own copy. Start date inside schedule is unaffected. Okay. So both copies are required. Miss the constructor copy and attack 1 works, and miss the getter copy and attack 2 will work. So both must be present. So the rule is for any mutable field type, make a defensive copy in the constructor, copy the argument, store the copy, and make a defensive copy in every getter, return a copy, and never the internal reference. So currently we have other alternatives also. You can use immutable types. The best solution is to avoid mutable fields entirely. Use java.time.localDate instead of java.util.date. Local date is immutable, no defensive copy is required. Okay. And the entire problem will disappear. This is exactly why the java.time API uses immutable classes throughout. Local date, local time, local date time, these are all immutable. They can be stored in immutable classes without defensive copies. Okay, so if we have to discuss a few rules, summarize what we have discussed is rule 1 is declare the class as final, prevent subclasses from introducing mutable behavior through method overriding, And rule 2 is all fields must be final. The compiler prevents reassignment after construction. One assignment in the constructor and never again. Okay. And rule 3 is all fields are private. External code cannot directly access or modify fields. And rule 4 is set fields only in the constructor. One place for initialization. After the constructor returns, the object is frozen. Rule 5 is no setters operations return new instances. Okay. Never modify this and create and return a new object for any result. Okay. And obviously there is another trap rule, defensive copies for mutable field types. If a field is a mutable type like date, array list, any array, etc., copy it in the constructor and copy it in every getter. Okay. Never store a received reference directly. Never return the internal reference directly. Okay. So thanks for your time. If you have liked this video, kindly share, like and comment here. Also, our OCP site is up. You can check it in java ocp.clustermicro.com. See you in the next video.